All right, welcome to section 11.6, and we're going to calculate standard deviation and know what it means. All right, so we're going to keep doing statistical stuff here, and honestly, the calculate the standard deviation is not the hard part. Your calculator can do it. There's actually websites that can do it. You just type in the data, boom, 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 it spits it out. Know what it means, I think, is actually much trickier, and I think there's many adults that if you said the standard deviation for this data is 5, or whatever this data is here, they would just have no clue what that means. So I really want to focus on that part of it, know what it means in this lesson. All right, so the Mr. Westphal definition for standard deviation is how far the numbers are spread out from the mean. Okay, so like mean or average is one way to kind of analyze data, but if you want to take it a step further, you could look at how spread out the data is or are. Okay, so I have two sets of test scores here, test scores 1 and test scores 2. They both have a mean of 50, but based on this definition, which of them do you think has a larger standard deviation number? All right, so pause the video and see if you can answer that question based on the definition. Okay, and so the answers are this set of test scores is going to have a higher standard deviation. Right? They're farther spread out from 50, right? Both have a mean of 50, but here all the students scored pretty close to 50. Here I had some kids not do so great and some that really, really rocked it. Okay, so, and that is significant, right? Like if I just knew that the average was 50 on the test, well, it's very two different stories, right? Here I can say, oh, the kids are probably all doing okay. They're about average, right? But here I'd say, well, I got some kids I really need to help because they're really, even though the mean was 50, I had some that were really low and some that were really high. So I should really probably be helping these kids. Okay, so the actual finding the standard deviation is actually the same thing we did on the last lesson. It was part of these one variable statistics. In fact, it is this one right here, this little O with a little line on it. And so to get the standard deviation, you just have to do the stats again. So I'll walk you through it here real quick. So you just hit stat and then go to edit. And then again, you pretty much want to use list 1 if you can. If you use the other ones, that's okay. You'll just have to switch using these list keys up here. But I'm going to go up and hit clear and enter, and that'll clear out all the data that's in there. And now I just got to enter my new data. So I'll do maybe the first set here. So I'm just going to type them in one at a time into right here. Okay. And once I have them in there, I'm just going to hit stat. And then I'm going to go over to calculate this time. I'm going to do one variable statistics. And if you have an 82, it might not even show that. Sorry, an 83, it might not even show this screen, right? But on the 84 pluses or whatever, they'll show this. And you don't really need to change anything as long as you use list 1. And then hit enter, and then it'll spit it out. So you can see our mean is 50. And then remember, there's all these data down here. If you're doing a box and whisker, you'd have your 5 numbers for there. But I just want standard deviation in this case, so that is just going to be 2. It's just a little line right there. Okay, so our standard deviation for this was 2, and that low number means they weren't all that spread out from the mean of 50. Okay, and then this one should have a bigger standard deviation, so I'll just pause the video and do that quick. Okay, so I just cleared them out and entered in list 1, stat again, calculate, one variable statistics, enter, enter, enter. And so my standard deviation here is 16.2, so much higher, right? And that again tells us that they're just farther spread out. Okay, so all you gotta do is get it in your calculator and then find this little squiggle thing right there, O with a line. Okay, so because they're more spread out, their standard deviation number was much higher than the first set. And here's like a more mathematical definition if you want this. I like mine. They're just how it measures how far they're spread out from the mean. That's how I like to say it. Here's a little formula, but realistically, your calculator is doing that when you do your one variable statistics. You just got to know which one to read off of there, right there. Kind of a summary of variation, just is like how far the numbers are spread out. So the range, if you haven't talked about this, this is just the high minus the low. The IQR, I think we talked about the other day, is Q3 minus Q1 minus the 2 quartiles. This is standard deviation. It's a little squiggle thing. And then variance, I'm not honestly sure why they have both standard deviation and variance. It's just another measure of how spread out they are. So the bigger the variance gets, the higher the numbers are spread out. And all it is just the square of the standard deviation. So if standard deviation was say 3, then variance would just be 9. Okay, but they both measure how far the numbers are spread out from the mean. All right, and I think that's kind of it for calculated. I'm not going to do any more calculate examples because it's the same steps over and over again. Right, so you can go back and watch if you need to, but you just enter them in the stat menu, list one, and then do one variable statistics and look for this little symbol. So I want to go back into like what does standard deviation mean a little bit more. So I have a question to help you try to make sense of this. So let's say I did a survey of 1, 2, 3, 4, 5, 6, 7, 8 teachers, and they were all 40, right? So the mean would obviously be 40. So right with the little X bar like shows up on your calculator, but what would be the standard deviation and the variance for this data? Right, if you had to guess. Okay, and the answer is 0, right? There is no spread out from the mean, right? They're all exactly the same as the mean. So the standard deviation would be 0, and then the variance would just be 0 squared, which is just 0. Okay, so this would be an extreme example where the data is not at all spread out, and so the standard deviation would be 0. Okay, so the next kind of piece of this puzzle, which leads into the next lesson a little bit, is if we have a set of data, like say 50 is in the middle, and say the standard deviation is 10. So maybe I'll draw a visual picture of this. We got 50 in the middle, okay, and then standard deviation of 10. So if I go 10 in either direction, I would be at 40 and 60. So say that these were test scores again. If you fell anywhere between 40 and 60, like 41 or 58 or something, you'd be considered within one standard deviation of the mean, right? Because you're within one um, chunk, one 10 unit of 50. Okay, and so then like we could say what would be two standard deviations. So if we had the same mean of 50 and standard deviation of 10, all that would mean is we'd go out another 10 in each direction. So now it'd be down to 30 here and then up to 70 here. So you would say anywhere from 30 to 70 falls within two standard deviations. All right. And so they'll ask these kind of weird questions where they'll say, if here's our data, how many standard deviations do we need to go out to cover all of these? So again, I'm going to try to do this sort of visually and just say, okay, here's my picture for two standard deviations. 50 was in the middle. And so we can see that 32 falls in that range. It falls right there. 25 falls outside of it. So it's going to take more than two standard deviations to cover everything. Same thing with 21 would be down here. 58 right now is okay with two standard deviations. 72 falls outside of that, and 37 would be okay. Okay, so the answer to sort of this question, this weird question on the bottom here, is 3 standard deviations, right? Because if we go out one more, if I go down 10 one more time, I'd be at 20. And if I go up 10 more up here, I'd be at 80. And now I've covered all my numbers, right? I covered the 71 that wasn't covered before, and the 25 and the 21 that was not previously covered. Now that I've gone out 3 standard deviations in each direction, I've gone 30 down and 30 up. Now it's covered in that, right? Because 3 standard deviations would be 20 to 80. And I've gone up 10 each direction 3 times from 50, up 30, down 30. All right, so let's do at least one more of those because that's kind of a confusing concept. But this is hurricane strikes by decade. So here's the different decades they've had. And then the mean number of hurricane strikes in a decade is 17.6, so almost 2 a year. This is a 10-year period. The standard deviation is 3.5. Within how many standard deviations from the mean do all the values fall? All right, so basically I would draw this like number line out and then just do like we talked about, like the mean in the middle. Okay, and then one standard deviation would be going up and down by 3.5. So I've just got to add 3.5 this way and subtract 3.5 going this way. Okay. Oh, sorry, this was 17.6, not 17.5. That would be nice if it was 5. So the math would come out a little bit easier, but unfortunately it's 17.6. Okay, so up here then if I add 3.5, I think that would be 21.1, and down 3.5 here would be 14.1. So we could see, does that cover all of this data, right? It covers this one, it covers 15, 20 would be right here, but now 22 it doesn't cover. Okay, so I would just go out another one, but really what matters here is you just got to look at the lowest and the highest, right? Because if it covers those two, then it covers all the other ones. So here's my lowest, I think, and my highest is 24. So let's go out another standard deviation and see if we're still okay, or not still okay, if we are now okay. So I'm going to add 3.5, right? And that's going to put us up here at 24.6. And then go down 3.5 a second time. So that would put us at 10.6, I believe. I'm doing the math right. Okay, and so that would cover 12, right? 12 would be right there, so we're okay on this one. And then 24, it would just barely cover it because it would be right there. Okay, so the answer to this would be 2 standard deviations because once we went out twice, we covered all the possibilities. Okay, and as we'll start to talk about in the next lesson, a lot of data, if it's called normally distributed data, most of the data will be centered around the mean, right? And we won't have to go out too many standard deviations to cover everything, right? And that's kind of leading into our next lesson. All right, so final thing I want to have you do, actually, I'm not going to have you answer on Schoology. I just want you to pause the video and think about it. This is, again, making sense of standard deviation. How you calculate it is just on your calculator. You're looking for this little thing here, right? But the actual make sense of it. So last test, 4th hour scores had standard deviation of 5%. 5th hour had a standard deviation of 8%. What can we conclude? Pause the video. Importantly, this does not mean that 5th hour did better, right? They had a higher number, higher standard deviation of 8% compared to 4th hour. It's not what it means. It doesn't mean better. It means they were more spread out, right? In fact, they could have done worse, but they would just, been centered, more spread out from a lower mean, right? So again, it's a measure of how spread out they are. So all we can conclude, we don't know which had a higher average or did better, technically. All we know is that 5th hour's scores were more spread out from their mean. Right? So whatever the mean was for that class, they're more spread out in 5th hour than they are in 4th hour. Right? That's the point of standard deviation. It's a measure of how spread out the numbers are. Thanks for watching.